On this edition of SciTech Now, we put on our hard hats to learn how laying bricks by hand may be a thing of the past.
What we've done for really one of the first times on a construction site is we've taken a trade, a value-added process, and we've helped increase the productivity of that.
SciTech Now's Hari Srinivasan talks about the future of wearable devices. Learn about the battle against the threat to the Great Lakes. Find out how big data is making it hard for us to keep our personal information private online. And cheese lovers, listen up. We'll show you the science behind the Swiss, or the Gouda, or the cheddar. I'm Simon Perez. That's coming up on SciTech Now.
SciTech Now is made possible through the support of our members.
Mohawk Valley Community College. Your future starts here, offering education and workforce development ranging from hands-on to high-tech, including nano, manufacturing, electrical engineering, and more. More information at mvcc.edu.
And by Giotto Enterprises, whose companies include Fiber Instrument Sales, The Light Connection, Molding Solutions, and Firmer Precision, providing solutions for fiber optic, telecom, molding, and CNC machining industries. More information at giottoenterprises.com.
Hello, I'm Simon Perez, and welcome to SciTech Now, our weekly program bringing you the latest breakthroughs in science, technology, and innovation here in Central New York and across the country. We start with a breakthrough in the masonry field. Robots are laying bricks on work sites here in upstate New York. Construction Robotics is a company based in Victor, just east of Rochester. The startup has developed a system that helps masons by taking over the repetitive and strenuous job of lifting and placing bricks. WCNY took a drive to Victor to learn more about an innovation that could change the future of masonry.
It was back in about 2007, Nate and I were talking about our various careers. Nate has spent many years in the construction industry with a general contracting company, and my background is engineering, manufacturing engineering. And Nate really expressed the frustration and what he saw as the inefficiencies on the job site, on the construction site. There's so much manual labor involved. Everything is a very manual process, very slow process. When you look at automation and you look at factories and how they leverage automation and robotics, they're able to take advantage of the benefits that robotics and these automation systems can bring to the table. And one of the first applications that we felt was a great fit was masonry. It's a very repetitive process, very manual process, very predictable process, which is perfect for automation and robotics. SAM is short for semi-automated mason. And what SAM does, it works alongside the worker. It's not a fully autonomous robotic system. You can't set it up and then come back a day later and a wall is built. It's very interactive with the worker. It's a little bit of an interesting space that we're in, because we're not building equipment that's like remote controlled. You know, you're not sitting at controls driving like a backhoe around. And you're not also setting up, again, a lights out factory where you just set this thing and come back a day later. It's really this in-between space. It's this in-between space of you set up a certain workspace for this robot to work within. And then once it's set up, once you define the workspace for this robot to build the brick wall, then it can run fairly autonomously within that space. You need to feed it bricks, you need to feed it mortar, and you need to interact with it whenever it has an issue. It'll tell you. It says, hey, come pay attention to me, fix this problem that I see. And so it allows the worker to leverage some of their time and effort. They can set it up, they can get it running, they need to keep it fed with bricks and mortar, but then for the most part, the mason will follow behind the system.
A lot easier on your body, first off, because you're not doing all the work yourself. It's just tiring on your body, really. Tiring on your elbows, your joints. Right now I have tennis elbow from handling a trowel. So it really just takes a lot of that. Now my job mostly consists of tooling, making sure the bricks are in right alignment. I'll eventually, every once in a while, I'll run up there and stock it. You have two guys running the system, the guy on the wall and the guy up there running the pad and stocking usually and keeping mortar.
Two of the biggest challenges that we discovered early on was how do you correct for the movement? When you take a robot, again, when a robot is typically used in a manufacturing environment, it's a very predictable setting around it. So it's bolted to a floor, it's on a concrete pad, it can drive around very easily, it can move around. When we take a robot onto a job site for masonry applications, you're typically building vertical walls. So you're going up story after story. And when you get up in the air, you need a way to get up there. And what is used on construction sites today is a mass climbing work platform. When you mount our system to that platform, it's moving around. So it's like being on a boat. So you're up in space, and as stable as this platform is, it's still swaying with the wind, it's still moving as people jump up and down. So, I mean, when you're up there 5-6 stories, you literally feel like you're on a boat. So you're taking this robot, it's picking up a brick in this case, going to the fixed structure while sitting on this boat, so to speak, and trying to find the exact spot where it's supposed to put it, correct for that movement, and then place it there. The other major problem was how do we deal with the mortar?
Well, when it first started, most of the focus was trying to understand the properties of the mortar. So we were looking at mortar rheology, we were looking at what we had to do with moisture content, anything that we can do with the mortar to have it work in our system. And the focus right from the beginning was to try to work with mortar that the masons are using. So we didn't target trying to create anything new. We wanted to understand what we can do with the existing mortar that they're using and understand the products or understand the different physical properties and control them and design them to work in our process. We're kind of doing the opposite of what masons do. Typically masons will put the mortar on the brick or on the block and then lay another block on top of it. We're applying it and we have to invert it and have the mortar stick in a suspended form. So from that point we went on to looking at the process and trying to apply the mortar and see what we can do to make it robust enough to have existing mortars stick. So it's kind of a balancing act. We can modify the mortar to some degree with moisture content. Well, as much as possible, we want to make a robust process that works with the mortar that they're using in the field.
In my opinion, it's pretty revolutionary. What we've done for really one of the first times on a construction site is we've taken a trade, a value-added process, and we've helped increase the productivity of that by actually helping to perform that trade, taking some of the manual physical aspects out of that. I think that the transition that we'll see over the coming years as technology evolves, as it advances, you will see a little bit less interaction with the system. The system will get smarter. The system will it'll build its own intelligence. There'll be other robots and other processes that help feed the system easier and faster so that you don't have to be placing every brick on the system. Same thing with the mortar. But I think that there will always be someone there to help set things up, to help monitor. So eventually there may be a day when, as this technology advances or other technologies advance, there may be one technical construction person that can run 3 or 4 systems. But I think there will always be a worker there.
Earlier this year, Construction Robotics won the World of Concrete's Most Innovative Product Award. Who knew there was a trade group for concrete? Let's move on now and find out the latest on wearable devices. SciTech Now's Hari Srinivasan sat down with Wall Street Journal columnist Joanna Stern.
So why is this wearable technology explosion happening right now?
I think a lot of it has to do with how popular smartphones have become, right? We're holding these devices in our hands all day long. I mean, literally, I walk around the city all the time with my phone just glued to my hand, looking for the time because it's replaced my watch in many places. I'm looking for that really important email, and sometimes I'm looking to see how much fitness activity I've done because some of these wearable fitness bands pair with our phones. So I think it really all stems from how reliant we've become on our smartphones. Why don't we take this technology to our bodies?
Right, and some of them are turning into jewelry as well. I remember I saw a company called Cuff.io. They made very high-end fashion-looking jewelry, and then they actually had the jewelry that you could press as a panic alarm in case, something bad was happening. It would send an alert to all 15 of your friends telling them where you were exactly.
Well, that sounds really functional to me. I've seen some jewelry pieces that blink when you have a Facebook alert. So, I think if there's some functionality to some of this stuff,
right,
that can be very useful. The other stuff could be just sort of this sort of prop technology.
Right. And I was a relative early adopter. I've been wearing a somewhat smartwatch for maybe 6 months or so. Mm-hmm. But why are they all taking off? Apple just released a new one, kind of validating that people are interested in this and maybe they'll buy the Apple version.
I think it goes back to right now, what's the next evolution after the smartphone? The smartphone or the iPhone really took off 5, 6 years ago, right? Now we're sort of looking for what's that next big thing? What's going to change our life? And I think in many ways, this wearable stuff is coming back to the more personal side of technology. These are devices that are going to tell us more about ourselves and sort of enhance our days. The question is, do a lot of people actually want to have that stuff literally invade our bodies? Do we need that? Do we have the opportunity to step away from this technology?
Okay, so you've got a couple of examples. What's on your wrist now?
So this, I like to refer to this as the mini smartphone that I put on my wrist. This is the Samsung Gear Live, and this is an example of Google's efforts to get into this space. This is the Android Wear platform that they've released, and this is one of the first watches that runs this software. It sort of brings the best of Android to a small screen on your wrist, but the problem with many of these at first has been that it looks like a smartphone screen. It's a shrunken smartphone screen, and this thing is pretty chunky.
Right.
I refer to this as my jail bracelet. This is what they put on me if I need to go track myself. And then actually you can see another big problem here. This says it's at 12% battery life. It's been a problem with these. I'm constantly having these things die. This is the Motorola, a little bit better looking device, right?
But it's totally black because?
Yeah, no battery, no battery. I charged this one yesterday, didn't have time to charge it again today. And also they require these special charging docks. It's not really a universal thing, so can't come over to your house and say, oh, do you have your watch charger? We're gonna have 2 watch chargers.
Right. So the charging problem is enormous for lots of people because technically a watch is something that they didn't expect to have to charge so often. It's supposed to keep time, not waste time.
Exactly, and I've been saying, my main requirements with these is as these get more functionality, let's be smarter about the functionality they get. I don't want to have every single email I get on my phone on my wrist. I don't want 1-800-Flowers bothering me for their new sale or Gap's bothering me about their sale. Right. I want just the things from the people that matter the most to me. So we have to be smarter, or they have to be smarter as these things develop. What are the things we want on our body?
So it's still sort of the engineers leading the charge, and the kind of user interface or usability experts are kind of lagging behind in this.
And I think it's also that design question too. The engineers in many places are designing these things, and you mentioned the jewelry. I think that's a big step in the right direction. How do we get some of these lifestyle brands involved? We've seen Apple taking steps in that right direction with the release of the Apple Watch, really sort of looking at, okay, you're not going to want to wear the same sort of band on your wrist when you're working out. You want that plastic band when you're working out. Right. When you go to work, you might want that gold band, or you might want to have that sort of stainless steel band. So there's a lot in that direction too, which is not really the core of the technology industry.
Joanna Stern from the Wall Street Journal, thanks so much.
Thank you.
Experts say as wearable devices become even more easily connected to our cell phones, manufacturers could ship nearly 500 million devices by 2018. From coast to coast, biological threats to our water supply are a primary concern for environmental scientists and citizens alike. One of the biggest problems is when algae builds up quickly in a body of water. From the Gulf of Mexico to Lake Erie, these harmful microorganisms can have serious effects on our water supply.
I saw the algae and it was really kind of a neon green. I was surprised at how neon it looked. It is very distinct once you see an algae bloom, and you don't want to touch it.
You better not touch it. That's an HAB, a harmful algal bloom. It could make you sick and kill your dog if you are both unlucky enough to fall in. Researchers at Ohio's Heidelberg University have been studying water quality for 4 decades. The team is gathering water samples on streams that feed into the Maumee River, which flows into Lake Erie.
Automatic samplers are set up to take samples 3 times a day, every 8 hours for an entire week. And inside that station is a refrigerated sampler, and every Monday we come out here and exchange the bases.
In the 1960s, pollution and algal blooms almost killed Lake Erie. After that, phosphates were banned in laundry detergent. Phosphorus was reduced and things got better. But in recent years, algal blooms have been making a comeback, and Heidelberg researchers think they've found out why. It's called dissolved phosphorus. It's said dissolved phosphorus is like a power bar for the toxic algae.
If you were to ask 5 years ago, dissolved phosphorus, everybody would scratch their head and go, what's that?
And they now feel that that's really the component, one of the main components in contributing to the algal blooms. We like to think that we know everything that's going on out here, but sometimes it takes a little bit longer term of sampling and database and data analysis to really start to see trends.
Though there are several sources of dissolved phosphorus in Lake Erie, scientists believe most of the problem comes from farm fertilizer.
The other ones all contribute, but the one that contributes the most or puts in the largest portion of the load is agricultural runoff. And so we're trying to get farmers to not apply more than they need and modify the way that they apply the fertilizer. And we think that pretty much those two things together will solve the problem.
This year, the Ohio Farm Bureau began promoting ways to better apply fertilizer using the right amount at the right time.
This farm has been in the family since 1890.
The Myers Farm is near Toledo, less than a mile from Lake Erie.
My great-grandfather is the one that first started this. My son's the 5th generation.
Bill Myers says he's been applying fertilizer the way the Farm Bureau recommends for years. It's just common sense, really. It bothers him that farmers are so often blamed for the algal blooms.
The people that will listen to these interviews or read the articles in the paper, the point they don't understand is there isn't some great big pile of phosphorus someplace that the government gives us for free that they say, hey, use all you want. It's expensive. It costs hundreds of dollars an acre to purchase and apply.
Best agricultural practices that reduce harmful runoff can be expensive. That's why programs like this one, that help farmers grow cover crops in the fall, are so important. Brett Margraf has been using cover crops for years. Still, this is not a common sight in northwest Ohio, at least not yet. The radishes aren't for eating.
Kind of small.
They're for holding soil, water, and nutrients in place over the winter so they don't get in the lake.
In theory, in the upcoming years, we should see a reduction in what we use for nutrients to grow the same quantity of crop.
Next spring, corn and soybeans will be grown here. Margraf sees it as a small step forward to improve the health of Lake Erie and maybe help his bottom line. And it works for conservationists who are looking at the bigger picture in western Lake Erie.
The complexity of the system, the fact that it is a whole system, requires coordination and cooperation. You know, there's a lot to do at the farm level, but at the end of the day, the impact on the sustainability of the system comes from a large number of farmers and a large number of constituencies working together to achieve sustainability.
Ohio lawmakers are close to passing laws that would ban spreading fertilizer and manure on frozen soil in the western Lake Erie Basin. SciTech Now's Hari Srinivasan joins us once more to break down what big data is all about.
What is big data?
The term was coined, I'd say, about 10 years ago. Originally, it was meant to refer to data that is too big in volume for traditional technologies to process. The term later got generalized a bit to refer to other qualities of data besides volume. There's the so-called 3 V's. The first V is volume. The other two qualities are velocity, how fast the data is coming in, and variety, how varied is the data in its structure. And those 3 qualities of data were just not well supported by traditional technologies, so we had to have a lot of thought and engineering put into rebuilding these technologies so that they could handle those types of data.
Explain for us, for example, all the big data that surrounds Netflix, right? So I, as a Netflix user years ago, I would give thumbs up and thumbs down and 5-star ratings to different movies, but multiply that by hundreds of thousands of other people, and what do you end up getting as data sets?
Yeah, all those things are contributing to the big data. I would say the thing that really pushes it over the technology limits is the smaller events that are happening. As you're watching a movie, Netflix is going to record what bandwidth you're getting so that they can optimize the pixels and things that are coming in to make it a greater experience for the customer. They're constantly sampling, finding out, well, how much bandwidth are you getting? Is it okay to increase the quality of the video so that you can see more clearly? So these types of things are far greater in volume than the number of times you're rating a movie, right? So that's what pushes them over the limit and causes them to have to re-architect their entire technology stack to support this humongous size data.
What are you able to do with that kind of information?
So if you're watching a movie, say on an iPhone where you're over Wi-Fi, they're going to stream you in a different quality so that you're not going to hit those pause events while it rebuffers. Whereas if you're hardwired into a line, then you're going to be able to get more bandwidth through there, so they'll increase the quality of the movie so you can see things more clearly, even in high definition. So that's one example of what they're doing, whether they have to capture data to be able to make those decisions in real time.
What about, say, for example, in areas such as healthcare? We're all generating tons of pieces of information every time we go to the doctor's office, or nowadays with lots of smart watches and smartphones and health apps, right? So what happens to all that data, and really how do we mine it so that we can actually find some value in all that information?
It used to be your vital signs, your heart rate was taken a few times a year on trips to the doctor. Now you can do it 24/7, right? When you're wearing a smart watch, it's constantly taking your heart rate and other vitals. And so that's generating a lot more data than the 3 times a year that we're used to before. It's constant. And so you need to store all that data, and then by browsing through that data and sifting and teasing out the patterns, you get to detect a lot of interesting things, such as how well somebody's sleeping now, right? You can detect, are they really sleeping, are they in REM, or are they just tossing and turning by measuring vitals.
Okay, Eric Colson, a Chief Algorithms Officer at Stitch Fix. Thanks so much.
All right, thank you, Harry.
Internet experts are especially concerned about privacy as more and more people store personal information on the cloud. Why do some cheeses crumble while others seemingly melt on the cutting board? How does string cheese get its form? There's a science behind all of it. In this next segment, we take a look at the physics of cheese.
Physics plays actually a lot of roles in cheese making. Most of them come after the cheese is already made. So after you've made the curd and separated it from the whey, then you need to make cheese out of it. Luckily, we know this guy by the name of Isaac Newton who can actually figure out what to do this for us. So what I brought here today is I brought a couple of little demonstrations of cheese presses. This is a home cheese mold, right? And the way you press cheese is you take the mold and you put the cheese in there, and I don't have any in there, but you put some cheese in there, set it down, you put the lid on top, and you press it down. Now Isaac Newton tells us that every force has an equal and opposite force, right? So if I set this down on here and the cheese keeps it from falling, or from falling all the way down, that means that the weight of this water is pressing down on the cheese is pressing up on the water, and we're going to actually press all of the excess whey out of the cheese. This is pretty handy. If I set this on here, I get about 8 pounds of force pushing down on the cheese, and that works out pretty well. The problem comes in if I have a bigger wheel of cheese, right? And if I put 8 pounds of weight on that same wheel of cheese, it's not going to press as well. So what we have to worry about is the pressure that we're pressing down at. So 8 pounds distributed over this larger area is going to give us a less pressure per square inch, which means that it's not going to press quite as well. And big industrial cheese manufacturers, they actually have air pressure or water pressure that will push on something to press the cheese down, and they can dial in the pressure for big wheels or small wheels or whatever they have, okay? But for home cheese making, or people who just like to make maybe artisan small pieces of cheese or small wheels of cheese, you have to do something else. Now this is a cheese press that was made for home, and this is a pretty handy thing because I can set this down on here, and this is just 2 little plates that if you push down on one, it pushes down on the springs. Remember Newton's third law, equal and opposite. If I press down on here, it presses on the spring presses down on this. If I put this in here, it'll press down on the cheese. The tighter I twist this down, the more it's going to press down on the cheese, right? The problem is how do I figure out exactly how much I'm pressing down on the cheese? And this is where we get to use some more physics, something called Hooke's law. And it is a law that describes how a spring will press when you compress it. Okay, so if I take this gallon of water, which is about 8 pounds, and I set it on here without dropping it, you'll notice that it compresses the spring, right? That same compression weight means it's going to be delivered to this bottom plate, and it's going to push down by 8 pounds, right? But of course, I might want to press by more than 8 pounds, maybe 16 pounds or 32 pounds, so what am I going to do, right? You notice when I push down by 8 pounds, the spring compressed this much. That's 8 pounds of force delivered to this bottom plate. If I want to go 16 pounds, all I need to do is compress the spring twice as much. That's Hooke's law. Okay, so now I have a variable press, so I can push this down after I've calibrated it. I can spin these little guys down like that, spin this one down like this, And then when I let it go, Newton's third law still holds. The springs are pressing down with now twice the weight that we had it pressed down before. So it's now pushing 16 pounds down on this, and if I want to push it at 32 pounds, I can push it way down and get as much pressure as I want.
Even through the perspective of science, cheese is pretty darn Gouda, any way you slice it. You knew that was coming. That's it for this edition of SciTech Now. For more information on science, technology, and innovation, visit our website at wcny.org/SciTechNow. And you can join the conversation on Facebook and Twitter. Next week on SciTech Now, discover how a Central New York man who used to be homeless is now redefining how we power our lives. Then learn how video game skills translate to the real world. Hear from an author who thinks exploring Mars will help us better understand life here on Earth. And we see how scientists studied coral reefs in a time before scuba equipment. I'm Simon Perez. We'll see you on the next SciTech Now.
SciTech Now is made possible through the support of our members.
Mohawk Valley Community College. Your future starts here. Offering education and workforce development ranging from hands-on to high-tech, including nano, manufacturing, electrical engineering, and more. More information at mvcc.edu.
And by Giotto Enterprises, whose companies include Fiber Instrument Sales, The Light Connection, Molding Solutions, and Firmer Precision, providing solutions for fiber optic, telecom, molding, and CNC machining industries. More information at giottoenterprises.com.